All right, let's see if the internet, which is a connected set of tubes, will work for me tonight. Looks like it is working. It means the tubes are connected. The data is flowing. Time to do coding. Right, I have been working on Programmable Data Parser for a while now, and today I'm going to work more on an image visualizer or an image display tool that I can plug into the user interface for the parser. And I'm not immediately integrating it into the parser. I'm first developing it offline in the bridge is what I call it, which is the parser that compiled as a Lua module so that I can drive it with the script. And that's mostly out of convenience. I don't have to keep opening up image that we want to plot. It's just going to go immediately to a hard-coded GIF file and parse it as a GIF, find the color table, find the image. Right now we're just printing it out to the standard output, but I'm trying to build up this prototyping window where we can display the visualizer. Hey there, striped monkey. Hello, beautiful striped monkey. This is pretty much where I left it. Hey, the Syrian, how are you doing? I don't think we need these anymore. I think I've done as much as I need to for the Lua wrapper for this thing, because that's not true. That's not true at all. It's gonna need the data to plot. So hold on. Maybe I should just put that in now. So the data we want to plot, it's two steps, right? It needs a color table and it needs the pixels, but I already have pixels in the form of this color table. It keeps rewriting it. It thinks it's Ruby for some plain text. We can actually see the color table in VS Code. So one way to test that the visualizer is working would, the easiest way would just be take the elements of this color table and send them in as input, right? It's going to need the color table eventually anyway. So yeah, I think that's why I was assembling this colors here. So pass in colors. Let's see. Don't think I need this one anymore. Actually, I needed that one. We're gonna need that one in a second. I'm gonna bring in eGUI and WGPU and all that stuff. Don't need that or that or this. I don't think. Well, I know where to find that one if I need it. Okay. Arranging things so that it sort of makes sense to me. I don't think I need data component. Close that for now. Title and color table. Here's the thing. What's the type of that gonna be? I think it all comes down to when I create this as a function, the arguments have to be from Lua multi. So it's a generalization of from Lua for arbitrary number of Lua values. So I think how that works is that all the types that implement from Lua work. good one, probably, right? Maybe not. So I just want to go to from Lua and see, ooh, 49 implementations. Here are all the things we can convert to Lua. Or into Lua. Value. What kind of value is that? Value. What the heck is value? Lua value? I should like have browser up ready to show here. MLUA. API reference. What's valued? Dynamically type Lua value. Okay, so here are all the things, right? Could be nil, boolean, light user data, integer, number, vector, string, table, function, thread. I wonder why vector and table are different. Oh, by default, vectors are 3-dimensional. Okay, so it's like vector as in like linear algebra vector. Actually, wouldn't that be oh no, yeah, XYZ kind of thing. All right, so I didn't know Lua had a vector built-in type. I think we're gonna end up using table. Okay. So this would be would you say Lua table? And that should build? Nope, not quite. Destructor cannot be a what? Not be a value? Oh, because it's const. No longer const. Okay. Mismatched tuple found. Oh, because this needs to be up here. Okay. Isn't everything a table in Lua? Almost everything. But I don't think any of these 49 implementations have vec in there. Oh wait, there is. Okay, so I'm wrong. So I could turn it directly into a vector of integers. Why don't I just do that? That's pretty cool. Can I do it that directly? That's ultimately what I would like to get. Huh. Okay, that is true. We do not need to own it. Mismatch types, so let's just borrow it. Hey, it works. Let's add some debugging to make sure that that actually is working the way I thought. So, println reseed color table. Terminal, please. Cargo build it. Building, and then run. Error converting Lua table to U32. Expected number or string coercible to number. Why does it think it is a single U32? Yeah, we never got that far. I suppose I should look at play with Tokyo? No, I haven't played with Tokyo. Hope it evolves to be as simple as Go routines. Like it for your project, interacting with kernel security modules. Okay. Haven't really run into any need to play with Tokyo. One thing that I did that's sort of on the same, like on a similar topic, I did notice that the built-in standard library stuff includes like, oh, why did I end up there? I went the wrong place. This one. If you just look up like, maybe it's not in the main one yet. It's like executors. Okay, maybe it's in futures, right? Not in the main standard library. But, you know, everything is sort of based off of the futures crate, right? I was looking through this the other day, and I saw that in the in the executor module, they got like a lot of things in here that I thought people use Tokyo for, like thread pools, spawning additional tasks. You know, you can make a custom thread pool through thread pool builder. So the only thing I've used from this so far has been block on. This is just super useful in itself. Because you just take over the current thread and block on a future. So it's how you bridge synchronous and asynchronous stuff. But, you know, I was looking through here, I'm like, oh, there's also a thread. If I wanted to, I can make a thread pool and like send tasks off to threads there and then not have to worry about the thread that it's running on. I thought that was neat. I think async Rust is really complex to master and be good at. Same with C++ templates. I think you're right, and I think it's because Rust async hasn't finished its evolution, and there's still some way to go to get to where everyone's happy with it. I think problems of the network. Loopback is still wait. That network LO is still runtime specific. Oh, IO. Runtime specific. Yeah. So for that kind of stuff, instead of Tokyo, I picked. I wanted to be sort of not locked into. Well, that's not true. I wanted to stay close to the standard library in Rust. So one thing that stays pretty close to that is the async standards. Is that what it's called? Is it async IO? This might be it. I can't remember now, though. I guess I'd have to look. It's been a while since I did this stuff. This may or may not be it. This doesn't look like it's actually it. The one I was looking for, their whole philosophy was to just have an asynchronous version of what's already in the standard library. I don't think this is it. Is it async standard? Is something called that? No, I'm just not remembering what it is. I'd have to go look. Yeah, too much distraction. I'm sure you know what I'm talking about, though. It was basically you can use the same like standard network stuff, but it had like an asynchronous equivalent, and their whole philosophy was they're trying to stay close to how the how the types worked in the standard library, only making it asynchronous. based on ePoll. ePoll rings a bell, but I don't quite remember it. Okay, so the problem here I'm trying to figure out is why it thinks that I want to convert it to a U32. I'm wondering if is it just I'm trying to go too far. Maybe I need to go to use size instead. So it's not a compile time thing. So there is an implementation of it. It's just when Lua passes it, it expecting a number or string coercible to number. So I've confused it somehow, I think. Either that or I'm not understanding how vec_t implements from Lua. Yeah, I think I'm just not understanding. Type system is okay with this. Window and lib. Window from the top and window at the bottom here. I guess I'll just look it up. mlua pass table as vec u32. Whoop, I completely misspelled that. That's an internal Lua table, but how do we like pass it in? This is a user data. I know how to do that. Wait. Why did it not just put that? Wait, what is this? Okay, it's slightly different than Google. Typically need to iterate over the Lua table, extract the values, and convert them into Rust vector. See, I was hoping I could avoid that. See, I thought that that would just be automatic. Wait, I've dealt with this before. Just it was more than a year ago. It's in the bridge here under data value. I remember doing this because there was like a value to Lua. It was the other way around. Lua, well, okay, I guess I did it for Lua to value. So for vector, what did I do? I created a table and I pushed them directly into the table. Okay. And that T is table, right? So maybe I do need to maybe it needs to be balanced with that. So I would get a table and I had to pull the values out and convert them from Lua to Rust. Question is, do you believe the confuser? Is AI a confuser? Sometimes it will get on. It'll miss but be near the mark, and I can kind of figure out the distance between. I haven't had AI go totally wrong direction on me. Last time I used it seriously was trying to figure out how to do string searching for the main UI, which I should make sure I still have, right? I didn't really show using that much, so I guess it's worth showing now. But to make that work, I talked about a little bit about it in Discord, but I since I'm not familiar with the theory behind like fast string searching, um, I just had UI like point me in the right direction, and it sort of did, but it didn't get all the detail right. But I was able to like bridge the gap between the detail that it tried to give me to what actually needed to be done. Ah, not what I want. That's what I want. Oh, yeah. I moved things around a little bit. I moved everything into the examples thing, right? So what are we opening again? I forgot. Data file first. I decided to move everything to examples. Hog slide. And then, oh, I guess GIF was already loaded. So when I was doing this search bar, let's say you type like 5. Well, there's a lot of things that contain the character 5 in there. And this is exactly how I wanted to operate. It quickly told me there's 32,344 matches to 5. If I do 5, 5, now it's down to 3,233 matches. And if I do 555, it's down to 183. So it's very fast. And I knew that could be done, but I didn't know the technology needed to do it. So I had AI point me in the right direction. It didn't get it completely correct, but what ended up giving me, I'll show you. I built it into data tree, I think. This search thing. So it led me to this FST crate. And it turns out that this crate and a lot of similar ones are all made by the same guy. And he's got some beef with the owner of the lib.rs site, which I found kind of like an interesting political aside. But anyway, it gave me it pointed me towards a solution with FST that used regex, and it was totally broken. But FST turned out to be the correct thing. I just needed to replace regex with something else, and so I kind of went back and forth with the AI, and it turns out that where did I actually end up doing it? Down here somewhere. Update search. So it turns out that you need a non-finite automata from the Ahokorosik, and that's it's named after two computer scientists who came up with the algorithm a long time ago, and it's the same guy made this crate as the made FSA. So they're kind of adaptable, but the author of both crates has so much other things that he does in his whether it's work or hobbies or whatever, that he never actually glued these types together. So I ended up having to take his code and because he still had the code in his crate, it just wasn't pulled into the main. There was no mod whatever to pull it in. It's this transducer module. So it implements this trait you need for FST, but for the correct automata that lets you do substring searches. And like it was mostly correct, and I think I took it from there. It was commented out with this note. He wrote it only to realize that it would create a dependency he didn't like. He decided to keep it in there but not build it. And then he also said he changed his mind. He's considering pushing it out, but he hasn't gotten to it yet. So I found it was broken in a few places, but after fixing it, I found that the tests work, and I was able to actually use it. But yeah, that's the long story short is I had no idea when I started that I would be able to find a solution with Ahokorosik or FSA, and the AI pointed me in the right direction. I just had to like build the last few steps of that bridge, which was to find this transducer module, get this transducer unanchored, and to connect the NFA, the non-finite automata, to the FSA hash, which is done where? Done here somewhere. Where's the actual searching done? The thing is, like, you have to sort it. So I used a B-tree map because the FSA has a particular requirement that you put the input in already sorted. So I had to sort it first. But where am I actually doing this? Is it this search result set? No, that's not it. It's the FSA thing, wherever that is. Oh, is it not here? It's gotta be here somewhere. I'm just looking at this too quickly. I'm getting the search results, so where does this searching actually happen? Oh, it's right here. So there's a search index which has the FSA map in it. And so it's kind of buried in there, but it's this actually does the search, and we get the search results as a stream. And yeah, it's just the traits involved are a little bit funny, but I end up iterating the search results, and I have to remember first get the token, because you can only, it turns out this map, you can only store bytes in it. And how does that work? It's like the output can be U size of that somehow. It was very, very constrained. So I had to like have a token to remember that for a particular U size, it matched back up with a row number, and then we recover the row numbers, and that's where we put it in there, this ordered search result. But yeah, anyway, that story was way too long. AI helped me do this searching, and it's really fast and nice. But I wouldn't have been able to figure out where to start without AI. But AI didn't give me a complete solution. I had to like get the last two steps out of the first 100 steps. Experience has been as too agreeable, and we'll try to go with what you want instead of telling me you're dumb and do it differently. My experience is that the AI is too confident in itself. And so I'll correct it and it'll apologize. And it's like, don't apologize. It's fake apology. Just like refine your search, because I'm like shifting the trajectory a tiny bit. I'm giving it some course corrections. It's kind of like, it's like, I got this, dog. I'll get you to Mars. I'll give you the exact trajectory and the exact amount of fuel to use, and I'll just get there. And it's like, well, you got close, but you need a little bit of a thruster course correction midway through. It's like, oh yeah, sorry, man. I that is totally my bad. I'll course correct now. It's like, okay, well, you overcorrected a little bit. It's like, oh no, sorry, I see, I overcorrected. I'll correct it. It's like, just don't be so overconfident and don't apologize when you're wrong. It's like, I expect you to be a little bit wrong. You're going to need some course corrections, because when it comes down to it, the language model is like, it only gets it so far to understand what I want and for it to get the correct answer. Not precise enough. So you have to correct it a little bit to get the precision. Would you just create a requirement so that the agent doesn't lose track of? It's probably smart. Yeah. I didn't have to do that because I think for the search thing, I only needed to correct it 2 or 3 times. What I found was really amusing is when I finally got it to agree with me that the answer was okay, was acceptable. It's like, wow, this is a very complex and creative solution. You should post it back to the author. And I'm like, I don't need to be flattered by AI, but okay. Found it amusing. I think it's because it's it's either set up or it's trained from a language model where people are just used to being overconfident, and when they're corrected, they say, oh yeah, you're right, I'm sorry. And then when you actually find the solution, it's like, wow, you're really smart. It's like, this is just all extra like politeness that I don't need. And I think with the requirements.md you said, I've seen other people where they configure the AI so that you tell it like, no, like you cut down on the politeness. Just be precise, and don't be overconfident. Say honestly what your confidence level is, and when you're corrected, don't apologize. And like, I could probably have done that, and I never would have encountered, had the experience I had. But I don't know, it wasn't too bad. It was actually more amusing than irritating to me. So yeah, a little side story about how I got the search, how AI helped me get that search stuff going. What I want to figure out now, if I click back on rate function and we see this from Lua multi, and then there's a from Lua, there's the 49 implementations. I really should just look and see how the vec_t is implemented. So here's how it's implemented, right? Table sequence values collect. That's sort of what we want, right? The self is a vector of t's. Oh, do I need to call from Lua? Is that what's missing here? Like, do I need to get a value? I need to have it come in as a value, and I need to tell it to just take the value and convert it, I'd say from Lua. Something like that, right? So this would be like a value, right? And then I would say mLua value. I'm not going to import mLua value because value is just too ambiguous to me. This clearly it's a Lua value, right? And so color table is a value, but let's parse that, right? From Lua, right? Did it need okay, it's the other way around, right? Or do I need to do the into Lua? No, it's from Lua but it's implemented on vector type. So what? So there's no self here, right? How does this work? What's that trait look like? So that's like an associated method, right? There's no self there. So it would just be, go back or forward or wherever we're going, back to window, right? Can I just see where from Lua is called elsewhere and get an idea? Aha. Right, so do it on the destination type that I want. And looks like I need to give it the interpreter for the second thing. So I would just do vec u32 from Lua, color table Lua, right? And that's what this guy is, so we didn't need before, but now we do need it. Oh, and this is, how does this work again? It's like vec, get this right? There is a associated from with a similar name. Okay, so I need to do use from Lua. It's missing the trait. Okay, it got further. So it can error, so I guess that means we will allow it to return early. Sweet. I think we got it. So the answer was, it's an associated function of the implementing type, the type that implements from Lua. And because vec is a generic, the syntax is a little weird here. I guess it should be able to have, I really didn't need to qualify that, right? Yeah, so we can figure it out from the context that the T is a U32. But I do need to say vec colon colon. Yeah, and the way I figured that out was I had done this over a year and a half ago one for my bitstream thing. Okay, I just lose way too much. Um, there's just so much stuff that you end up dealing with that you lose stuff. Did I not build it correctly? It's the same error. Just a sanity check here. In window new. I expect that to be actually printed out. And we'll get rid of the piping, redirecting to out just to test. Okay, so that didn't fix my problem. In fact, I'm exactly where I was before. Like, is it that it couldn't convert that? Let's see. If we get a color table, let's print it out. Recovered color table. I'm guessing that that's the problem that we're gonna that it's this vec from Lua it's failing in. That it really isn't being passed as the second argument like I think it is. That I screwed that part up. Yeah, okay, that's what it is. So that means probably the way I did it originally would have worked too. So what am I doing wrong in here? Colors is the second argument. Oh, I see the problem. That should... Oh, hold on. I thought maybe the problem was I needed to make it a method call. But no, it's actually exported as a free function. So the second argument is that... Hey there, A squared. Rela table. Brownoser. What if I say color table is I'll just print out what it is. Because maybe it's not what I expect it to be. It's a value, but what is it a value which has a table? And then maybe my understanding of Vex implementation of from Lua for it should have got into that case I saw where it took in a table, but maybe it's getting a different type or something. Okay, it is a table. But why is it trying to coerce it to U32? That's my issue here. Because like this should go what we saw before, right? It should be match value, it's a table, and it should get the values and collect them into a vec of U32s. The error wasn't expected table, it was error converting table. Is it sequence values? Table sequence and error converting? Okay, I don't know. I don't know where. See, this is in the implementation of MLua. I'm not exactly sure what it's supposed to do. Maybe the table contains a table? I didn't think it did, but you could. So here's how we build the table. Oh, I have a no zone for the mouse right now. Should we verify that like let's just print something like print first well colors 1 2 string. Actually, I could have just done 2 string on the table itself, right? Or no, that wouldn't work. I learned that yesterday. I don't know why I don't just write a, a loop for that. Here I think I do want to redirect to out and just have out open. Plain text. Oh, that is the problem. Okay, I messed it up then. I didn't put into colors what I thought I did. So Sarian was right. The table contains tables. Oh, why did I do it that way? For some reason I wanted to keep red, green, and blue separate. I don't know what I was thinking. It really should just be, we should put it in in the correct pixel format that we want. And I like RGBA, right? Or is it ARGB? ARGB, right? So it would be red shifted left 24 plus green shifted left. No, this is shifted left 16. Shifted left 8, right? And I'm not going to get any kind of lovely formatting from Lua. I don't have a Lua formatter. I'm going to do it this way. Whoops. Now what do I get? Oh, so yeah, I've already done that conversion. So it should just be 06x color. Out of range. This is out of range. Guess it doesn't, it's not, oh, it is out of range. Okay, so I must have screwed that one up. I mean, is it order of operations or something like that? These should all be numbers from 0 to 255. Okay, that worked. It was an order of operations thing. Okay, yeah. Then cool. I did it. So at the bottom, it should have printed out actually. There we go. Receive color table. Cool. All right. That was it. There again, kind of was on the right track there. Hey there, Bob the Rhino. Hello, world. So I don't need this anymore, right? Okay, and then in here, probably I didn't need that. I could have just said vec u32 all along, and I don't really need to do that at all. It means I really don't need the Lua interpreter. Let's confirm that. Yeah, I don't need the from Lua trait either, because I'm not using it. Yep. Yep. So it's all automatically from Lua for me. I don't need to do this. So the problem all along was that it wasn't a table of integers, it was a table of tables. Because I forgot I had done that. I had kept for some reason I kept the red, green, and blue separated. I don't know why I did it that way. Really, we do need to just combine it because when we print it and when we use it later in the graphics engine, we want it to be in some kind of pixel format, and I'm picking ARGB. Send that out of the virtual machine. We got to reboot. They got that bug with the mouse dead zone. So last stream, there's a whole lot of me like going off into the weeds describing what I'm doing. So instead, I'm just gonna like, if someone asks, or maybe periodically, say that what I'm working on is a programmable data parser, and it has its own domain-specific language. And you might be able to guess some of the commands. You can like look up what DSL is, and like if you know, maybe I should add to the DSL or the project command, like because you kind of have to know from there like that I'm using Lollerpop for the parser generator, and I'm using Logos for the Lexer. So parser generator and the Lexer are two key parts of a compiler, which you need if you make your own programming language. And then maybe like when I say that it's programmable and it has its own language, the language is for describing data. So for GIF, it looks like this. And for JSON, it looks like this. And that's really all I really need to say, and then I won't go off into the weeds with a deeper explanation, right? I'm hoping that this JSON is self-describing enough. Maybe it would be better if I put value near the top, though. Because value is really a key element of JSON syntax, right? Number document is a special case. I think I'm okay putting that putting it at the end, because really we don't really want to, don't need to see that at the top. If I were to open this, it's like, yeah, a document is a value, and a value is one of these things. And then it all kind of, like, if you see this opt white space, like, what is that? Well, that's here. It's where we're skipping white space. And here's an object. Here's a list. It kind of makes sense, I think, if you've seen JSON before. Yeah, I'm going to go with that. So if anyone else asks, and the bot commands aren't enough, we can just go into that. So we got the colors into the window. I'm not doing anything with them. Let's store them so that we can actually plot them on the screen. So I think it's just all we really need to do. We already have it in window new, right? We already have it here. Why don't we just transfer ownership into new, since like we just want to hold on to that and use it later to plot things, so we'll just hold on to it here. And then we just add color table here and we're done. And I don't need this received thing. That was just for debugging, right? Could be a const function again, because we're not doing anything that requires processing. It's never read, that's true. And that is also window. It doesn't like that I named it window, but the struct is called window. I think this is not really the window. This is like the window controller. I hope I'm not twisting the term controller too much, but it has the window, but it also has additional things that are needed in order to draw what goes inside the window, right? I don't know. Chat will tell me if I'm using if I'm not using the correct term. What does one do with the programmable parser? You parse files. So an example that I can quickly go to is this one. So this is a GIF file. It's PogSlide, and I should also just keep this up in the background, because then I won't have to keep looking for it. So your computer knows how to read this file in and show the animation, right? Well, let's say you're coming up with your own format for like an alternative to GIF, and your computer doesn't know natively how to open it and show it as images, right? Or let's say just because we want to learn more about how a GIF is packed into the bytes that go into the file, this tool lets you do some of that stuff. So by teaching it this GIF format, it knows it's kind of like a recipe on when you open the GIF file over here and you're reading the bytes from the file. It's a binary file, right? We can see that there's very little text in here. Maybe there's a GIF up here, and then like there's a Netscape string in there, but otherwise it's all binary. So it needs to know how to parse that, how to get the data out of it, how to make sense of the data. So the tool allows you to describe how to make sense out of the data, and it'll go through that recipe in order from the first byte to the last, and then output a data structure, which is the structure should be extracting the data that you want. In this case, it will have all of the individual frames in these graphic control blocks, and inside there it'll actually have the lookups into the palette of every single pixel in the image. And so there are 10 of them. That's because there are 10 animation frames. So in addition to the actual images, the image data here, there's also a control extension which has like delay time and other things in there. Like the delay time is what you adjust if you want to make the animation play slower or faster. And also like which entry in the palette is supposed to be transparent, so that if you draw a pog slide on top of something else, that it's not black, but it actually, you can see through it to what's behind it. I think window thingy is the technical term. Yeah, you're probably right. Hey there, Kevin. So there are other kind of cool things. In the past, I've described it as like, let's say you had a damaged GIF file and you wanted to know like, hey, can I figure out what's wrong with the file and can I fix it? So this tool, following through the recipe on how to parse it, it'll start highlighting things in red when they don't match an expected thing, like there's something wrong with the data, and then you can use that to like kind of zero in on what might be wrong. And because every time you click on something, it shows you where it is in the file, and it goes both ways. If I see something weird in the file and I click on it, it'll show me what that's interpreted as. So that 3D byte is the 25th entry in the global color table, and it's the blue part of the color because they store the red, green, and blue separately. So like the one after it is the red of 26, and then green, and then blue. So it's alternating red, green, blue, right, for every entry of the global color table. Anyway, some useful things. I'm really mostly doing this just for fun because I kind of find this stuff, I find it neat as well, and I find it challenging, and I find it useful. Yeah, so anytime that you open a binary file in a hex dump, and you wish that it could tell you more, this tool would be handy for that. You could either reverse engineer the format just by trial and error, or if you had a specification of the format, you could convert it into the language my tool uses, and then it would be able to basically you're automating the sequence of like figuring out what all the bytes mean. So yeah, I'm trying to get to where I showed how it decodes the image to indices into the color table. Well, we can use that to actually draw it on the screen, and that's what I'm trying to get to now. So I didn't want to do it in the main GUI because I don't want to have every time I run the main GUI, I have to like go and find the image again. It's like it's down here. Here it is in image data, right? I kind of want to just type a command like if I go into the examples, I just want to type lua view.lua and have it show the window. So that's what I'm getting towards now. Because I could put my parser in a lot of things. I could put it in a GUI, and I can also put it in as a plugin for Lua. So that's what this is. So when you do require bridge, it's bridging into my parser. So bridge has like a parser, bitstream file, and ingest. And we added window. And those are entry points into my code. So parser gets you something that is compiling the description of the format, right? That's what this is doing. And then bitstream file is saying, I want to open that file and ingest it as a bitstream into the tool. And that's what ingest does. So it this is where we pull together the how to parse it with the bit string that's input, and then what's the top level node. In this case, it's GIF. We could have picked something else, and it would have tried to parse it as something else if we did that. And then what we get back out, this GIF, roughly corresponds to, in the GUI, what you see on the right-hand panel. If I do this correctly like that, there's actually a hidden root node called GIF, and it has 3 children: header, logical screen, and data, right? That's what get back out here. So when you go to GIF and you look up logical screen, it's the equivalent of looking up this node here. Like logical screen has the description, which has the width and the height, and the I think we're grabbing the color table something, right? Color table size, color. What am I grabbing out of there? Global color table size. So that should be in here somewhere. Yeah, right here. Global color table size, right? 256. That tells us how many entries there are in the palette for the file. And then we're constructing the palette by we go back into GIF and we find the global color table, and then we're pulling apart those red, green, and blue values and recombining them into colors, so that we get something that looks like. I should not close this file because every time I open it, I have to tell it it's plain text. We get here's the palette, right? All the way down to the last entry is black, and so we can tell in the raw pixels that these are all black pixels, and you can see, we can kind of see that there's an edge there. There's an edge to Pepe. That's all we can really tell. Now we have to actually just plot that out in a window. So I'm working on that part. We get the color table in. I was going to have it just plot the color table first, and then we'll actually plot the decoded image. We have the decoded image here. No, here, image data, right? Right, I collected the pixels. Actually, I didn't collect the pixels. I'm actually just printing them out. But I suppose I could just pass in pixels directly back in and just extract the values out, because it's really just a big table, right? Probably what I'll do. In fact, what if I just get ready to do that now? We should get pixels in. So when we do here, we should get a vector of, they're going to be indices, so they're just U8s, right? And then we need to go to this, well, this has to be pixels. Go to new, expect that we get pixels. Spec 8. We'll hold on to them like that. So that should just work. And just to confirm, let's, in the new here, let's print them out. I got pixels. The first one is that pixels dot length len, and then pixels 0. Getting my languages confused. It's pixels length, right? Oh, and it's barfing because it's no longer a constant function. Tired of embedding Lua in your program? Embedding your program in Lua. Yeah. I could go either way. For the game I was designing years ago on stream, I was embedding Lua in the game, which makes sense when you want to have like mods for your game, right? You write them in Lua and you plug them into the game. Here I'm plugging the parser into anything that can that allows you to do require, which pulls in a linked library, a dynamically linked library, which basically exports functions and adds them to Lua through a module named after what you require, or well, that you get out of require, right? So Any place where Lua is put, it could be on its own standalone interpreter, or it could even be in a game somewhere. If it allows you to pull in linked libraries and use them, then my parser can be used there. I thought that seemed the most flexible way to do this, is let the parser be pulled into wherever Lua is, not try to put Lua into the parser. Now that it's running, I can run it, right? Cool. And that did exactly what I was hoping. Except for oh, I had to click it twice. I got 12,544 pixels. So that, I could confirm that should line up with, that number should match. If I go to that image and I look under, where would it be? Actually, it would be the length of that, which we can't really see. But another way we could check that is we would just multiply. We go under here and where it says for the image descriptor, right? It has a width and height. If we multiply those two numbers together, which I'm going to do on my calculator right now, just to make sure that it's correct. 112 by 112 equals 12,544. So it's correct. You can trust me. Do I have another mouse dead zone? I do. I can't click here. Got to reboot again. I can't click anywhere here. Oh, that's another way I could show Pog Slide. So I actually don't need this open, because that's the same thing, right? I can close that thing. Unfortunately, got to reboot. This is annoying enough and happens enough times that maybe I should have an on-screen counter for the number of for every time I have to reboot, we increment the counter. Number of times Raimo has had to reboot the VM is now 2. It'd be really painful if booting up was slow, but it's reasonably fast. So, and I can BS for the 10 seconds or so that it takes to do. So there, we got our Pog slide. Back to work. So I verified that we're getting the right data. I can remove this debugging stuff. It's going to tell me that that function can be const again, probably, when it's done updating. Hey, this could be a const function. Thank you very much. Make it const. Yeah, we're not using this yet, and that's what we're going to solve next. We want to actually use that stuff. So here's where it gets a little bit messy, because in Window, the only thing we're really handling right now is when you close it. We're not handling some of the other things we might want, like, hey, you might want to draw right now. So let's do a match event so we can see that. Here are all the things that we could handle. Let me just pick out the ones that I kind of care about. I care about resized. I don't care about move. We do care about close, requested, destroyed. I don't care. Dropped or hovered files, focused. Maybe we'll deal with focus later, because I'm thinking if you focus it, then maybe we'll want to start to show the row and column your mouse is over. Same thing with like mouse moved. Or I guess it's called cursor moved here. But I don't care about that now. I don't care about this yet. Let's just do basic drawing and resizing. Resizing is important because every time the size changes, we'll use that to remake the buffer that holds how we render to the window. We're going to use a graphics library that has a buffer. So we're going to need to know the size of that buffer. Mouse wheel, don't care about yet. I might care about scale factor changed if we do text, but we don't do text right now, so I'm not going to care about that. And okay, we definitely need redraw requested. So the close requested, we do this. If it's anything else right now, we don't care. Okay, let's print this out to confirm it works. Window size. Physical size dot what's physical size give us? Width and height. Wonder why it doesn't fill it in automatically. There we go. Physical size dot height. I hate typing, so I like it when it types for me. And we won't do anything here yet. To do. Keep a marker that we're gonna do something there. So let's build that. The way the symbolic link works, will it let me do like Lua examples view? Probably not, right? Yeah, so we have to actually go into the examples and then do Lua example view. So now every time I resize it, it changes the size there. So that seems to work. Question is, do we get an initial size? We do. So we get an initial resize. As long as that's exactly the same as what we so 1200 by 800. My question is like, yeah, so this one we could use to size our surface initially, and then we would just use this to resize our surface. So rather than coming up with this code from scratch, I'm going to copy what I did in the other GUI. I can't find it. I'm going too fast. Believe it is inside drawing, but there might be some stuff in app that I need to copy here. Maybe in the new. Is it in this info overlay thing? No. I think this drawing. Yeah, this has all the junk that we need to draw on the screen. I'm gonna need this. And it borrows from a window handle. Because surface borrows from a window handle. And this surface we don't get until we call new on drawing. Which we don't do until we actually have the window handle. Yeah, okay, I missed it. The surface, where's the surface come from? Okay, the surface, yeah, here's the nuts and bolts of if we're using WGPU to draw stuff, then we end up getting an instance to the graphics library, and we tell that instance, hey, please create a surface for this window, and the window we don't know until the create window is called. Create window is called when our app is resumed, right? So in our event loop, we'll be told that the event loop is resuming our app, and then we're free to create a window because we get the event loop out of that. We create the window, and now that we've created the window, we can also create a surface for that window, and this takes a immutable borrow of the window handle. So if I own the window, can I own the window and have a reference to what I own in the same structure, or is that asking for trouble? Here I avoided it by putting it into this. I put the window here, but I also kept something in another structure called drawing. But I gave that a static lifetime. What's the point of having? So this should just be surface static, right? Why did I even bother doing it that way? So I could just have made the surface static. Yeah. How did I do that then? It's a surface for some lifetime, but somehow we coerced it to be static. Does that create surface do that? No. So how did I make that? Oh, I know how I made it work. Cause window is an arc. Arc has a magical property in that what you put into it now has a static lifetime. I'm leveraging that. I remember yeah, yesterday I was asking myself, why the heck did I use an arc for the window? I had this I looked at that and like, that's weird. Why is there an arc there? And the reason is that allows the window itself to outlive the entire app. It has a static lifetime, right? So we can then hand out another reference, so to speak, to this drawing here. This lifetime can become static. That's why I'm allowed to extend it to static lifetime, because we're using arc. Okay, so I'm gonna do the same kind of thing then. I don't think I need to actually put them in different things. I'm just gonna do is just grab all this stuff, and we'll delete them later if we don't actually need them. I'm gonna see if I can just put them all here. I'll mix them in right here. Why not, right? There, and oh wait, there's a reason why I can't do that. We can't get this stuff until we actually have a window, and we can't get that on new. So I can't put them here. I have to put them somewhere else. But I can put window along with it. So I can just make another struct like window impl and put the stuff from drawing in there along with the window. Yeah, and then put window in there. And then we'll just do like window impl option arc window impl. Actually, I don't need an arc there. I need an arc here, and this is not an option anymore. That's what I want to do. Okay, so this stuff all comes from different crates that that don't have a lot of them in config yet, so I need to do that. Time to pull in some extra crates. So we're gonna need eGUI. We're gonna need basically all this, well, some of this stuff. Pull that up next to the one for bridge. I feel like I'm kind of violating separation of concern a little bit, but this really is only temporary, I think. Probably what I'll do is move it out of the bridge when I'm done. Or maybe I just leave it there. Like maybe let the bridge can open up windows. Sure, that's fine. I want these integration layers. And I want WGPU. And we're a little behind, but that's okay. What's really important is eGUI and WGPU. eGUI, WGPU, and GPU have to be compatible. So I can't just update one independently of the other, or else we get a type mess. Do we need anything else here? Maybe chrono? Because I saw something that might have been chrono related. I think it's from there. Actually, you know what? I'm just going to go to drawing. And just pull in all the includes from eGUI, WGPU, and just paste them here. Paste, and take all these things and paste them. instant standard time. Okay, here we use static. GUI integration. Oh, I made my own class for that. Why did I do that? I don't remember why I did this. It's so small. Do I just steal it for now and maybe get rid of it later? Yeah. Oh, or I can see how it's used here. How is this thing used? Well, we use it to collect the output given the platform output, which is just telling the state to handle the platform output. It's really just obscuring this eGUI W init. Okay, I'll refactor that later. For now, I'm just going to steal it. So take that, copy, go to bridge, and paste. Put in lib mod eGUI integration. Have to maybe make a note here to do reincorporate this back into window. This reach up and then back down again? Yeah, it did a use super that, which means that in app I must have done a pub mod or something. Wait, what? I just did a use. It doesn't need to be a pub if you do use super, right? So I can just do the same thing. Super, like that. Okay, so that gets rid of those errors. We'll call that window imp. I renamed that. Okay. Here's where we need a bigger thing, right? Fill structure fields. Window goes at the end. Got to fill in all the things here. We don't need a sum there because the sum is around the whole thing. Okay. What's the one error? Do I not have log? Wait. Oh. Let's just turn that into printf. This is probably going to get rid of that anyway. Okay, so no errors now. It's just that we're going to panic when we get here because we haven't filled that in. So this is where I'm going to steal stuff from drawing. How do we set that up? Lost my place there. It's resumed, calls create window, which makes the window, oh, right, here we go. So we have a context state, the GUI integration. We have our drawing resources, and that gets us almost everything we need, looks like. Oh, we're going to have to make that method. Paste here, right? So need comments. Comments are for the week. So this for now is just going to be let window. And I think the way I did this up here was I immediately put it into an arc. I guess it would go here. And we're making a clone here because we give it to this. So that means that this really moves into that. Actually, don't know why it's cloned twice like that. What's the problem with that? Why is it an option? Oh, because there's some. Okay. That should just be a let. Why is this cloned? I have no idea. Why are we cloning stuff? Why did I clone it back here? Oh, I kept 2 copies of it. Why? I don't know. I think it's because of the separation between these 2 classes. I don't need that, so we don't need to do this. Instance descriptor. Why? Oh, because that came from app, not drawing. This stuff. I'm wondering if I need to pull in more from WInit right now or just do it later. Okay. We just expect should be able to create surface for window. Okay, the width and the height we knew from here, right? And yes, I know these are magic numbers. Width and height. So yeah, all of these to-dos should go away because we should just have them. All right, what happened to depth texture view? I guess I missed this part. What's that called by? Wait, what? Okay, so at the end, I guess. So like right here. Depth format. Put that here. Create depth texture view. We're gonna need to steal this one. Probably gonna need make screen descriptor too, right? Actually, I'm probably gonna need to use a lot of this stuff. Those free functions at least, and maybe even the draw. We're gonna be stealing a lot of this stuff. What we call boilerplate. Yeah, let's just steal all of that stuff as free functions down here. Window. I think we're just going to always assume success. Expect. Should be able to get an adapter. Let's print line that for now. We need futures? Okay then, I didn't expect that. It's because that adapter request device is async, right? Yeah, impl future. So futures o.3 goes data tree, wrong one. Right here. Okay. Debugs, it's all print line. This is gonna be expect. Should be able to get an adapter. Wait, what's the difference here? Oh, should be able to get a device. And Q from adapter. Okay, get surface caps. I think we're just turning this into expect. Should be able to find. sRGB surface format capability. And this is just the tuple. Config device Q. All right. Back up here. That just works. This stuff. What do we initialize that to? Huh. I had it right there. And did I move window out? I did. I moved it on 125. So this should be dot clone. Add semicolon to last statement. And we're not using any of it because we're actually not drawing anything. But we will do that soon. So, okay, where do we use make screen detector? Right, in the drawing. Okay, so there are some things that we do when we draw. I think I'm just going to steal the draw method. Like completely. Oh, and why not handle the handle event resize while we're at it, right? And just make that part of window. So it would go like right here. Oh, not even in that, but in our own impl. Yeah. Just right there, right? N comes after D. Oh, wait, I'm putting it in the wrong place. This should be in the impl of window impl. Yeah, that makes more sense. All right, and then paste that there. Okay. Did that wrong. Info as a macro, all occurrences, print line. We don't have an info overlay. We don't need that. Some more functions I need to steal. Process GUI, render GUI, yeah. Update the buffers, update textures. Yeah, we need to steal that stuff. Okay, okay. Actually, I think I'm just gonna pull this out. This is just gonna use self, right? What does it do here? Oh, it has we're gonna have to have that, right? I think we're just gonna put it directly. Yeah, so that is doing this. And content. We need to I don't even need to show any content yet, right? So this content probably, yeah, it has like the actual contents. We could just have it do nothing for now, right? Yeah, it'll just be an empty window at first. So wait, why not just build it in here? Just do nothing. Yeah, we'll do. Duration comes from standard time. Max, standard compare. This doesn't take any arguments anymore. Okay, cool. So nothing calls draw, that's a problem. Or handle event resize. Okay, handle event resize. We had a place to do that, right? Right here. Right now we're printing something. I don't need to print that anymore. I just need to call self.handle_resize. Size, width, and height. If we have a window impl. Create this to size and we're done, right? Okay. Redraw requested. That's the real important one. That's where we actually call draw. Oh, there's some extra stuff we do here. Yeah. Okay. So we have to run it through the integration layer, and then if it asks us to repaint, and the redraw requested is the event, then we draw, and we're setting control flow accordingly. And then if the event is consumed, we return early. Yeah, okay, so it's handled a little differently than I thought. We don't actually do it there. We do something front here. Okay, so then we have to have a window, so let impl. And this is where I chose this. Did I put that under window impl? And that's an RC, so I don't need an asref map, do I? So it's just feed input event. Found option. Turn an option? Oh, it returns an event response. So what did I do wrong here? Expected event response found option. Oh, this doesn't return an option. It actually just returns an event response. So it just says, just say let event response equal that. Okay, so then this is window impl handle redraw. Wait, I have a window handle redraw. Where is it? Do I not? I guess I don't. Okay, well, why don't we just do this? I don't even need all of that, do I? We'll just it used to be that we're pasting that, and then what do I actually need here? That's what next. Okay, so we don't need that. I might need this stuff later, but I don't now, right? I just need to do, it's not drawing, it's window impl raw, right? Thought I made a draw. Yeah, there it is. Wrong types though. It doesn't have an info overlay, it just has an app start. Okay, don't need this thing anymore. What's that? Wait, unwrap the impl value? Oh, did I not unwrap it? Oh, I already unwrapped it, so there's no self in front. Okay, draw. And that works, actually that shouldn't work. That's taking immutable. We'll probably hit that error in a bit. I don't actually have messages sent back from the UI yet, but I might later, so let's keep that there. We don't need that. Let's see where control flow should be imported from. I don't want to make the mistake of importing from the wrong place. winit event loop. Okay. So my guess would have been correct. Okay. This is self.window.request window impl window request redraw. Yeah, okay, so here's the problem with draw. I don't think it needs to be mutable. What happens if we just make it immutable? Then we're updating. Okay, so we do need to update stuff as mute. All right. Okay, we're good. Have some few warnings to clean up. Yeah, we're not drawing anything yet. That's expected. And we didn't use the app start. When did I ever use it before? Huh. Did I miss something? Oh, it went into here, which actually didn't use it. So I don't need that. Get rid of it. Not there. Here. I don't need app start. Don't need that. Okay, cool. So let's just run it. It should actually, instead of having a window frame, it should actually draw the whole window. And it'll have all the pieces that we need to do graphics. It's just that we're not actually doing any drawing of any graphics yet. I could have put something in there like hello world. That would have been smart, but I didn't do that. That would be here in draw, right? This thing, right? Nope. Process? Yes. So here it would be like I forget how to do this. It's like UI dot like label or something. Text. Hello world. Right? And we don't care about the response. I'm gonna wait until it's finishing compiling this before I save it again. Save, and now we'll actually show something. So it should show a hello world inside the window. All of that boilerplate. A lot of work. Okay. Hey, look, we got a hello world. Look at that. It's a very small hello world, but it's there. I guess I'm dumping a bunch of stuff on the print line that we don't really need. Okay, so we're getting there. So we have the whole stack. eGUI at the top, and then WGPU in the middle, and then WInit at the bottom, so to speak. So I did a lot of copying from the other project. Maybe I should just do a quick run through, and then that'll, in a duck typing kind of way, help me make sure I did this correctly. So when the Lua script asks to make a window, we will go into the new function. We will get the title of the window, the color table, and the pixels that we're not using yet, but we'll use later. And we're going to make a new window controller and return it back out, which means it's got a fit as a Lua value, which it does because window controller implements user data, which is the Lua user data, right? And specifically, it has one method called run loop, which we use in the Lua script to actually draw the graphics. So in the new for window controller, we're just we're not really doing anything yet. We're just we're saying we have no implementation of the window yet. So we have the pixels to draw. We know what the title of the window is going to be, but we haven't created the window yet. Because the way that eGUI works is you have to give it control in the run loop. So that's why I had that extra method called run loop, which I put. Where did I put that? I put that in the implementation of user data. So what we do is we ask eGUI to create a run loop with no, basically with user events. Actually, I don't even think I need that. But right now we're not doing any user events. We're not using that for anything at all. So it's a builder pattern. So when you're done, so we have nothing more to say with this isn't eGUI. Let me back up. This is we start from the bottom. So we start with WInit. This is a WInit event loop. WInit event loop. So go to WInit, which is the crate that allows you to like create a window on the screen. And it's cross-platform. So for us right here, it's Linux. So it'll go to X11 and create a window. No, first it creates a run loop, and then the run loop tells you when you're ready to create a window. It used to be you created the window first, but to support multiple windows, you first create the event loop, and then with the same event loop, you can create more than one window. The way it works is you first build the event loop, and then you tell it to run your app, and your app has to implement this application handler. And this run app never returns. You can't, it's not guaranteed to ever return. It might return. For some OSs, some implementations will return when you close a window. Others, the program just exits. So run app starts the event loop, and the first thing you're guaranteed to get is a resumed event, and you get access to the immutable access to the to that same event loop that we created back here. We get it again in the resumed, and then what we do in the resumed is we create the actual window. If we get it, we put it in an arc so that it can outlive everything else. It has static lifetime now, and that's important for later. And here's where we build up the upper levels of the stack. So we make a context for eGUI. We create an integration state between eGUI and WinInit. And right now I have this helper class that holds on to the the integration layer. So I called it eGUI integration along with the window. And that's what I'm considering folding back into later. And then this is the middle layer, the WGPU. So this gets us an instance to the graphics library. So for Linux, it would be Vulkan. For macOS, it would be Metal. For Windows, it would be DirectX. This is an abstraction layer on top of that. So in all of those graphics libraries, you can ask the graphics library to create a surface if you give it a handle to something that the OS can map to the screen somewhere. So in this case, it's a window. We give it another reference to the window. That's the reason why we created an arc, an asynchronous reference count, because this is going to borrow the window handle. So we put it into an arc so that we can let it borrow it without worrying about the lifetime. Effectively, the lifetime is static. So this window lifetime is static. So we'll end up with a static lifetime surface, which is what we want because we're going to eventually store it back, hold on to it. The surface is the interface between the graphics library and the upper layers, like when we want to draw to the surface, we use the surface as a handle to it, right? The surface has a configuration, and that's like the width and height of that surface and the color scheme, and I have a helper function to do that here. So we go to the graphics library and say we want an adapter, and there are multiple adapters because another level of abstraction. You might have both DirectX and Vulkan on Windows, right? So it has to pick one. So here's where it actually picks one. We'll end up printing that out. So for Linux, it'll say got an adapter for Vulkan. And then there's an asynchronous method to request driver access to that adapter. And you get two things back out if you're successful. You get the device, which is like the driver access, the overall driver, and then the queue is what you use to send commands to the driver. I don't exactly remember why they're separate objects, but I think it's important because of separation of concerns or something. But when you request a device, you have to describe the device constraints. So we're saying like use default memory hints. We want to go up to 8K texture sizes. We want limits that are compatible with WebGL2. Everything else is pretty much we don't require anything special. So if you had exotic requirements on the graphics library, you would list them here, I guess. So then we get the capabilities of the surface, and from that we can list the formats it supports, the different graphics modes and alpha modes and all that junk. But we use the device to configure the surface. And when we configure the surface, we have a descriptor for, so WGPU is all about descriptors. There's a descriptor for the device, and there's a descriptor for the surface. So we're saying we're going to, I think render attachment means we're going to use this surface to actually draw to the screen, to actually render things. And then we say we're going to want the surface to support RGBA8 or BGRA8. Forget what norm means, like not normalized. It says here, red, green, blue, and alpha channels 8-bit integer per alpha. 0 to 255 is a converted float 0.1 in the shader. That's what that means. Those are typical formats that most adapters will support. Another really big important part of the surface config is the width and height of the surface, and then like how we're going to present. We're going through a FIFO with the queue. I think alpha mode. Let's see, what is alpha mode again? Specifies how the alpha channel of the textures should be handled during composition. So we're saying that we want to the alpha channel if exists of the textures is ignored in compositing. So basically, we want we're not drawing any transparent pixels. Everything is opaque, and other miscellaneous things that we have to set. So ultimately, we get back the surface. I saved the surface config, I think, because later when we get with the window resizes, we got to change these width and height and then reconfigure the surface with that. So rather than like building this whole thing every time, I think I built it once, and then I return it so we can mutate it later. The device in the queue that we got from the adapter, we return back out. And that goes back out. And we have it here. The eGUI renderer needs the device, the format of the surface. Depth format is how the texture format we use in the depth buffer. So 32-bit floats, right? Yeah. Forget what the 1 stands for. MSAA samples. There's a lot of like graphic library terminology here, where they're not using dithering. So I'm doing one MSAA sample, no dithering. We hold on to that eGUI renderer because we use that later to actually draw to the surface from eGUI, and that's where it gets a bit more interesting to me. The depth texture view. So whenever we need like a texture, we go to the device and we say, hey, create us a texture. And again, here's a descriptor that describes what we want. And we say, hey, we want, what's extent 3D? Oh, that's just the size. We have to tell it how big. So it's only depth 1. It has the same width and height as our surface. MIP count 1, sample count 1, 2D texture. Same format as our depth. So basically we're making the depth buffer here. And we're saying we're going to be using it with textures and with rendering. And then after you create the texture, you create a view to that texture, and that's how you handle it. So we store that back because we're going to use that later. So we end up with that depth texture view, the device that talks to the graphics driver, the eGUI context that we made way up here that holds on. I think it's it connects into this eGUI within it because it's got a copy of it and also uses its viewport ID. I forget what that stuff is. We hold on to that for use later. The integration layer, the renderer, which we'll use to draw. The queue and the device, yeah, we stored that. We store the surface and the surface config to reuse later. We hold on to the window. And then I use this later for like figuring out when we last drew, when we're supposed to draw next, that kind of thing. Whew. So a lot of initialization stuff. We get back out. We set up in resumed, right? So then once we've created a window, now we've told the event loop that, hey, we're ready to receive events back on for that window through, I think, the same application handler. We get a window event. And there, since we only have one window, I just ignored the window ID. But if we cared, I think what we do here is when we created a window, I think you can ask the window what its ID is, and then you could save that somewhere and then match it up with the events. We don't care though. We get the same event loop back that we did in resumed, and we get the event. And here's where it gets the painting is complex, so I was skipping that for a moment. If we resize the window, then if we have, this is making sure we actually have all the tools that we made with the window. Do I actually need that? Oh, I don't, because we already got it out here. So then I can actually just do that, right? Yeah. So we get a resize event. We take the new size, and like I said before, I held onto the surface config so that we can mutate it. And then you can just take the surface you got and reconfigure it at any time. As long as you still have a handle to the device, you can say, hey, reconfigure this surface with this new surface config. So when the window is resized, we just reconfigure the surface every time we get the event that we got resized. And then we have to recreate the depth texture view because the config changed. And that goes into the width and height here. If we didn't do that, then our depth buffer would be the wrong size. So we have to recreate that. So that's resize. Close is easy. We just when we tell the event loop to exit, usually what happens is that call to run loop returns. And then we could go and we could make another window if we wanted, or we could just do whatever. Sometimes though, this just quits the program and you just You go poof and you never return, right? So drawing, that's the harder part. So we're going through an integration layer that kind of pre-processes events, and it's got something called onWindow event. So this is in eGUI W init, and it kind of translates some events that eGUI cares about. So like scale factor change, mouse input becomes a responses in eGUI. Basically, we're letting eGUI have a crack at any window events first, right? And after we let it have a chance to handle the event, then what we get back from eGUI, if eGUI says, okay, because of that event, I need you to repaint, I have this comment here because sometimes it's very aggressive in repainting. We only actually repaint when we get a redraw requested event. Otherwise, we're going to queue a request to repaint. We're just going to go to the window and request that we get a redraw. And that's to avoid the lag that can happen if events queue faster than we're able to repaint. So multiple request redraws, these get flattened into one single redraw requested event, which goes back into the queue, and then the eGUI will mark it as repaint, and if it matches the event, then we actually draw to the window. And then I have this next draw time because we can decide whether we want to redraw immediately, because sometimes eGUI will be drawing an animation and it's going to be like, well, I need you to draw immediately. Or I guess it's not immediate, right? It's either wait until something happens in the event loop, or wait or wait a small amount of time until the next animation frame. So then draw, we get into that, and we get to do our own drawing if we want to the surface, or we can just let eGUI do all of it, which is probably what I'm going to end up doing. So the way this is set up is you ask the surface to get the current texture, and that's what we're drawing to, and then we'll create a view into the texture of where we're drawing using a default descriptor, and then we're creating a command encoder. So this creates like a temporary context where we're saying, hey, we're grabbing the output graphics texture and we're going to draw into it. And then we process eGUI, and there we're taking the input from the integration layer with the window and passing that to the context and telling it to run. And there's a callback when it comes time for us to do to like what to fill into the window. And this is inside of eGUI itself, and there's a whole bunch of like stuff. And this is sort of one philosophy of eGUI, is that when you want to draw something, you tell it to take control and you give it a callback that it calls when it's ready for you to do your thing. So when we want to do our thing, we're like, well, we want eGUI, we want you to make a panel in the center of the window with a 10 pixel margin around it. And inside that, we want you to draw a label that says hello world. And I didn't say anything else, so I think the default is default font size aligns to the left and the top of the window. So that doesn't immediately draw to the window, and you can tell because it doesn't have access to the surface of the draw texture yet. It ends up just filling the eGUI context with instructions, and then it'll pick up those instructions in a bit. So you go, you get the output. That's right. It doesn't go back into the context. The instructions on what to draw ends up in this full output, and the full output is like non-rendering related output, and there's a whole bunch of textures to use, and there's shapes to draw, and there's a viewport within the output in which to draw. So it's like graphical constructs, right? So we let the window integration layer take the platform output, which is the non-rendering related stuff. So it's like what cursor to show, what things to put in the clipboard, right? Stuff like that integrates with the Windows system. And then the update eGUI textures is now taking the graphical part of the output, the textures that changed, and update the textures in in the renderer. So yeah, we're taking the textures from the output and we're updating them in the renderer. And this is in the integration layer between eGUI and the graphics library stuff. Yeah, so there's a lot of stuff here. I didn't come up with this all myself. I think I copied a lot of it from eGUI examples, but hopefully I haven't lost you yet. I end up with this screen descriptor that describes the surface geometry and the density of the pixels, because when we ask the eGUI renderer to update the command buffers, it takes the driver handle, the queue, the command encoder, the triangles to draw, and the screen descriptor, and it just sends all the commands to the graphics library. So that's where it's actually telling Vulkan or Metal or DirectX or whatever to actually draw using that command encoder that we got that's associated with the output texture and all that stuff. And then render eGUI. Oh, I skipped ahead there. I went too far. Where was I? We get the textures. So we update the textures in the graphics library first. Make a screen descriptor. We tell we need to tessellate all the shapes into triangles. And then update eGUI buffers is taking all the triangles we tessellated from the shapes and putting them giving them to the graphics library. And then render eGUI says we actually want to take that geometry, all those triangles to draw, and actually draw them now. So to draw them, you make a render pass, and you render using that render pass along with the triangles and the screen descriptor. And then it's all assembled in like a big FIFO or a queue to send to the GPU. And this queue submit encode, you finish the encoder, and then you submit that to the queue, and that's just batch. It's sent to the GPU at that point, and that's where all the drawing actually happens. So when it comes back, the GPU is done, and so output present says take the output texture and show it on the screen. So like if you have double buffered, it'll exchange the front and back buffers. Like it draws to the back buffer, and then you present flips it to the front. And then I guess sometimes it doesn't need old textures, so we release them, so that releases some GPU memory. And then I guess this stuff is checking if like eGUI is asking us to when to draw next. So it's either we don't need you to draw anymore, so we're returning none, or we're returning some amount of time. And that's when we're in some kind of animation sequence. It'll return a delay. And I guess I map it into this next draw time because I am combining with Max the repaint after that came from eGUI and my own draw time comes from, all right, because I have something in here. If we wanted to keep drawing a certain interval, we'd do that extra code there. Yeah, this is figuring out when we should schedule a callback to draw again. And that took me forever to describe. I can tell by the lack of chat that you're all rapt attention, and now you're now all experts in how to draw stuff to the screen with the eGUI WGPU in its stack. So right now we're just drawing Hello World as part of the process eGUI here. And that's working. So instead of just doing label, I think we want to use the drawing. I think I just want to draw rectangles for each dot. Keep it simple. So we're going to take the size of the screen, divide it by, let's just make it 16 by 16 because that's how big the color table is, right? And we'll just draw colored squares that match what's in the color table. So I think that is UI.drawing or painter dot rectangle filled. And I've used this before, so rather than figuring out what to actually pass it, I'm just gonna, yeah. So my data tree did this to draw highlight rectangles. So, yeah. We can have rounded corner if we want, but I'm not gonna have that. Let me just copy this. So the fill color, hold on, let's keep that for a sec. Fill color is not going to be background, and we're going to put this in a loop too, like for color in self dot. Oh wait, we're in the window impl, right? So we sort of need this passed in. You know what we can do is we can just say the window impl just takes a sequence of colors. So color and colors, something like that, and draws them as rectangles. There's not going to be a label. And we're just going to assume that the color we can cast into a color 32. I think it can just take a U32. So if I just take color, that should work, right? And corner radius should be none. I don't want a rounded corner. Zero. Corner radius 0. And then the rectangle. Oh, that's right. Before we can actually use the painter to draw stuff, that we have to actually reserve space. So I do that over here, right? Somewhere here. This canvas offset column indent. Maybe we don't need to reserve space. Maybe I can just draw. What's min max do? I think I want min size actually. I want the min is like the top left corner, and the size is like how big to make it. You can see it makes the max as min plus size. Size 2. Did I get that right? The vec2. Has a x and a y for width and height. Okay, so and I have to remember they're floats. Same with position, right? So it's all in floating point. So let's just get like, wait, what did I do? Why am I in insert mode? I don't know how I got into that mode, but index? I forget, is it index and then the thing if I do enumerate? Because what we're going to pass in here is a list of U32s. Yes, so you get a U size, and then I need to convert that U size into a column and row, right? So let row equal the index divided by 16, and then let x equal index minus, or actually you can just do modulo, right? And then the whole thing needs to be converted to a float. So then that should work. And then let's figure out how big to make them. Because this will be like times size y. Size. The size y is going to be like the surface config width, so height, divided by 16, right? And this is probably a float. No, it's a U32. So I need to do it as F32s again. All right, and then x is going to be the width divided by 16. And then this just becomes x is size x and y is size y. It doesn't take color though, because you can't convert from U32. But if I dereference it, will it take it? No. Okay, if I use eGUI RGBA. From RGB, I guess, and then I just have to get the individual pieces out of it. I think that's right. Or do they have like from like from a U32? That would be the perfect way to do this. I don't think there is though. Let's just do from RGB. So the R part is color shifted right 16. And then as F32 divided by 255, right? And the green and the blue are similar, so we shift right 8, and this one we don't shift right at all. Oh, but I have to mask. Actually, just do mod 256. I think that's all I need, right? Okay, 2 errors. Process eGUI needs the colors now, so we need to pass the colors through. Okay, and then down here, draw. So here we're in the window controller, so we have the self.color. Yeah, so do that, right? Perfect. Then we have some warnings here. So we're not using the pixels still. It's probably going to nag me about loss of precision. I'm going to allow that. And that's so the only warning left is that we're not using the pixels, which I expected. So I'm curious to see if this will actually work now. If I did this right, it should show us the palette. And then I can kind of compare with what we have in the output file. So these colors here should match like what we see on the screen when we run it. And they kind of do, only that is not the same color as that. So we got some issues. I think what it is like I think I have it set up for sRGB instead of URGB, so I have to do a conversion. But otherwise, like 2, 3, that doesn't look It's like not scaled correctly or something. Maybe I just go with it now, even though the colors look funny. Maybe they're close enough, right? If I scale this down, yeah. So maybe what I should do is make the window not so big. The other thing is like, if you make it, like I'm not preserving the aspect ratio at all. So when I actually draw Pepe, it's going to look funny. I don't think I actually need all these events. Although it's kind of interesting, you can see the cursor removed events. There's also an axis motion event. There's where I do mouse wheel. If I left click or right click. There's a modifier. What is that? Mouse input, device ID, button left, button right, button middle. All right, got the color table. Let's now turn it into the actual image. So I just need to do a little bit of extra work here. Like instead of holding on to color table and pixels now, why don't we just make pixels U32s? We don't hold on to the color table anymore. And we need to remember the original size of, okay, I forgot to pass that in. We need to know the image's width and height. So, image width and height. And then the actual pixels. So let's just have these passed in as parameters. Then fill instructs does it automatically for me. So here, what I can just do is collapse I can make the pixels out of the color table. So I'll rename this to be pixels by index, and then we'll make another vector here. Actually, then this we don't need to own it. We're making a new vector out of it. Or maybe I just let the caller do this. That'd be easier, right? So this just becomes pixels U32. We don't have a color table anymore. What am I missing? There's a let. There we go. Okay. So we're not going to draw the color table. We're going to draw the pixels, but also it needs to know the image width and the image height. So we need that up here. So this is just rename that right now, pixels. Ugh. Height. Size. All right. Not using them yet. Here's where I want to use them, right? Because this size-wise is going to be surface height divided by image height. And this is going to be image width. And then the y is going to be divided by image height, image width. Don't need that one anymore. All right, so then we need to pass these in. So I got them up here, right? Just copying them through here. Should probably put this into struct. That make more sense? But I'm being lazy. Or I should say, I'm just not thinking. I'm resting my brain for a moment. So we can't divide a U32 by U size. So I suppose what I'll do then is I'll just say as use size there and there. Or does it make more sense to cast the height to require these to be U32s? No, because that index is already U size. U size is actually better. Either way, I got to cast, right? So I might as well just cast here. Okay, and then down here, pixels is the wrong thing. Also, we need an image height, width, and height. So I need the types up here. And I need the names in here. Oh, and I need to rename this pixels by index. We have to create the actual pixel vector from these two. Image width, height. Get that right? Title, pixels, image. How did I don't know why. Oh, because they're alphabetical, but I prefer to list them in argument form that way. Right, this doesn't take the color table anymore. Okay, so then a couple things. Before I forget, I should update this to include the image width and height. I knew I would need that, so I already got them up here. Okay, and then we have to construct the pixels. So let pixels equal pixels by index map. Well, iter map index color table index select. Oh, because yeah, it had to do use size, and that has to be dereferenced. There we go. So we're looking up every pixel by its index in the color table. We get back a vector of U32s out of that, because each entry of the color table is fully ready to plot color. So if all of this works, we should see Pepe now. But he's probably going to be in a weird... The colors are probably going to be distorted. I need to fix that. Oh, look at that. Got Pepe. Woohoo! We have successfully decoded an image and drawn it on the screen. Hooray. Actually, the color doesn't look that bad. Let's compare to Hog slide. So the colors look washed out. I think it's because it's the difference between sRGB and non-sRGB. I forget what the name is. I think I just need to do some color correction to get it right. I didn't get any reaction in chat. I guess no one's watching anymore. I'm happy I got him to draw correctly. Okay, so the pixels, so it's not using the whole window because it's making sure the pixels are all the same size. That's why it draws that funny. You're looking, that is cool. Well, hopefully it wasn't too much like indecipherable arcane steps to get here. And I'm glad you had the trust in me that I was actually doing the correct magic incantation to do this. Let me try to correct the color. So I think the problem is the color table is not in the right color space. So I wonder if I could just cheat and use the same color space when we set up the graphics. So where would that be? Draw close that in window somewhere right here, right? Where we set it up. In this long resumed function. So where do we set color space? It's I had a helper function to do part of this, right? Yeah, this stuff needs major like cleanup right now. Is WGPU init the one? It's probably this one. This format right here, right? What if I pick sRGB here? I guess it is this one, right? Or this one? This one. I think it's that one. Let's see if I can actually, if that'll actually work. Let me keep the originals. I even have a note here, sRGB. Let me see if that is enough to correct. If we can't do that, if the graphics library wants a different color space, then I have to figure out how to do the color space conversion. I have to look up the maths. Nope. Should be able, so we didn't find the right. So these are the formats supported. So we could do BGRAU norm sRGB. And then I just have to flip the red and green. What if I just do that? I'll do that right now. GR. Ultimately, don't we need to, like, whatever we pick, we need to put it in the correct color space anyway, right? The other thing is, like, I need to see how do we tell eGUI what color space it is, or maybe it just needs to match there. That should be a B. So if it's that, I don't know, does this actually change anything? Probably pressing my luck by not backing up my files. Do that now. It didn't have any effect. Colors still look washed out. What does that tell me? Probably that there is some kind of translation, and I'm giving the colors to eGUI. I actually need to give it in sRGB format, right? Probably, I think that's what that means. So, where is that done? Where does it actually say what format it has to be? Would that be in where we do the rectangle? Let's see. Color 32. Internally, this uses 0 to 25 gamma space sRGBA color with pre-multiplied alpha. So the pre-multiplied alpha is no, I don't need to care about it because the alpha is 1. So if we multiply by 1, it doesn't change it. I think the problem is that we don't have it in sRGBA. It's not the correct color space. I think I just need to, well, hold on. Wasn't there like a conversion we could do? Yeah. What if I do from one of these things, right? Maybe it does it for me. Like maybe I'm supposed to do from sRGBA unmultiplied or something like that. What if there's some transparency where there should not visually it look like that, or something is blending? Well then I think we would see it where the black pixels are too. And right now I'm not seeing that. Right, this looks black to me. It doesn't look like, if there was a solid color underneath, then I would expect to see a difference between here-ish and here-ish, where we're not drawing at all. We're not drawing at all here. We are drawing a black color here, so it's not additive. The other thing I could do is, instead of clearing with black, I could clear with a different color, just to verify that. Because the clear color is in one place. I just need to remember where it was. Probably we said black at some point, or clear. Here we go. So we can make it really annoyingly red. just to check that, right? Yeah. But let's check. Let's make sure the transparency actually we're not applying the transparency color, so it'll just be red on the borders, right? Yeah, see, it's just gonna be red on these borders. So that tells me that when we do draw, it is overriding and it's opaque. So we're not blending. Otherwise, it would have blended in with red and looked really scary. So I think it's just where we fill in, where we choose the where we give the color to the rectangle. Instead of doing from RGB, I need to do something else, like, I'm just guessing here. Maybe it's from sRGBA pre-multiplied or unmultiplied. Then we have to give an alpha. We'll just give an alpha of 1. Right? What did it not like about that? Oh, U8s. Okay, so I just do as U8. And this is a 255, I guess. So it doesn't like that it might truncate. So we're going to allow possible truncation. Quiet the linter. Okay, let me try that. It's either this or it's like the opposite of this. So if we're applying the transform in the wrong direction, it should get even more washed out. And then I just need to figure out what the reverse of that is. Oh, no, that corrected it. I think we got it. I think that should match. Did I not keep it open? That should match this. There we go. Yay! We got it. Through pure guesswork. All right, this is a great stopping point, I think. I am happy I got this far. Do need to clean up a bunch of stuff. So the end goal is I think I'd like this to pop up when we run the, hold on. When we run this, and if I hover over, actually, you know what I'd like it to do is, if I hover over this, it should just show me the image. Or maybe in the value column, it'll say like image, and if you click it, it'll pop it up on top, maybe. Or maybe when the row is selected, we would just show it somewhere, like maybe we would show it in the corner here. I don't know, I have to do something like that. So that's the integration of what I just did today with the original GUI here. Is that either somewhere on the window here, or maybe it pops up when you click something, or maybe it just hovers like that hovers currently. It would just hover the image instead. Let me make this a lot smaller. You know what we can do? We can leverage the fact that we know the width and the height. We can actually, in the window, we can use that width and height rather than the arbitrary numbers I had in there. What was it, like 1200? Yeah. So what if I just said that self.image height width? The problem is I have to account for, I had some margins and some other things, so I need to add some slot factors. So what if we add like, just a guess, this isn't counting the size of the border, so this might not be correct. But what if I do that? It didn't like the types or something out of that. Oh, this needs to be a certain type for inner size, right? Needs to be convertible to size, which takes logical, right? F64. So I guess if I just do dot. Oh, no. No. They both need to be cast. There we go. Still doesn't like it. U32? Okay. I guess there's some conversion that this P works with, right? I don't know. Or maybe when it goes into inner size, this into size maybe does the conversion for me. Well, of course. Of course it might truncate. Allow that, please. This is actually a great time stopping point because I need to wind down before sleep, and that's just about now when I would do that. Oh, I think it's too small. Wait. I thought it would go down to 1 pixel high, but it... Oh, there it did it. It's really finicky about it. That's weird. It must be rounding or something. Maybe when I do the calculation for when the draw, it's rounding down to, probably it's rounding down to 0. What if I do a min 1 on that? So that would be in draw. Oh, not this draw, but here. I really should refactor this out as like draw the image, right? This is the key here. I was hoping it would be like 1. Maybe that's okay. Let's print this out. And while I'm at it, let me find all the print lines here and like suppress some of the ones that I are getting in the way. Where was it again? Is it here? Yeah, this one. These events I think are overwhelming the output. They go to sleep after this next compile. Yeah, hey, Nightshade dude. You're coming in right at the end, as some people do, and I feel bad about that, but it says one by one. How come? Oh, you know what I bet it is? I'm doing rect filled, right? It's probably a 1 by 1 rectangle. It probably doesn't fill it with anything. It's probably too small for rect filled. Yeah, see that? It's okay with a 1 by 2 and it's okay with a 2 by 1, but it doesn't like a 1 by 1. Well, really the right way to do it would be to put it into a GPU texture anyway and let the shader do this, right? So that's probably what I should do. I should just do my own shader, draw it myself and not use eGUI. Well, but yeah. Okay, so for now, let's do a min 2 on that. And then I'll make it, or max 2. And here 2. Here. And there. Oh, it says I don't need those. Looks ugly, but hey. And then the initial size, where I had the fudge factor here, let's multiply by 2. Yeah, I don't respect the aspect ratio right now. I was just being quick about it, and like, because there's so many other boilerplate details I was dealing with, I'm like, I'm just going to let it try to fill the window. So if you want to fill it that way, you can. If you want to fill it this way, you can also. But if you make the window squarish and the image is also squarish, it'll just work. The right way to do it would be to compute the image aspect ratio, which is the image width divided by the image height, and then compute the window aspect ratio. And like, you either want to put black bars on the left and right or the top and bottom. To and then you want to make the pixels themselves squares. And that's easy to do in the geometry where the x-axis and the y-axis are the same units, but it can be tricky on surfaces where that's not the case. Then you have to map it. You have to make sure it's square after it's translated into the surface coordinate system. It can get really complicated. So yeah, this is a very inefficient way to do it, and we're finding that it has a limitation that it can't make the pixels smaller than 2 by 2. So the right way to do this is to put it into a GPU texture, have basically just draw a quad, so 4 points and 2 triangles, and let the fragment shader copy from the texture to the surface. Then I really don't even need eGUI. The only reason to use eGUI would be that it's easy. It's very easy to then integrate it into the existing app here, which uses eGUI to draw everything. I would just like say, well, make it a pop-up or draw it in the corner here or something like that. So yeah, I'm happy. This is working. This is a nice default size. I guess the fudge factor I didn't need. Oh, I know why. I am not doing the size reservation correctly. That's what happens. See, it's drawing all the way to the edge, even though I did a border. I put it into a frame. It's supposed to have a 10 pixel border. But when I actually am using the UI to show and I'm going straight to the painter, I didn't reserve space. And so it's ignoring it's completely ignoring the bounds of the frame and just drawing it. So really I didn't even need the frame, right? I just could have done that. That would work too. Oops, wrong thing. You know, if I keep going like this, I'll be staying up too late. This is where I hate ending the stream because I'm having too much fun. Yeah, so it's the same thing, and oh, actually it's a little different in that it's not clearing the background anymore. Okay, yeah, so without a frame, it's not clearing the background, so it's some kind of default grayish color. So maybe I keep that for now. And then it's at least drawing the background color in black. Yeah, see, now it's drawing the right and the bottom in the same black color that I told it to before. Code does that to a person. You've seen worse UIs. This is very low budget, I know. Oh, but I guess we'll just leave this up while I. So this is the original PogSlide.gif. This is where I've used my programmable parser to extract the first animation frame from that and mapped all the pixels through the palette and drawn them in a window. I know, it's awesome. So a lot went into that. A very roundabout way to do what is already built into VS Code. So I'm staying true to my principles of reinventing the wheel for fun. Ooh, we can rate Adam. I think I'm going to rate Adam because I haven't rated him in a while. So here, it's time for something completely different. I'm going to rate Adam T. Eunice. He does a mix of coding and pixel art. He's working on a game. So please be nice to Adam, and I hope you have a lot of fun on his stream, and hopefully he's not ending now. He's only been going for 2 hours, so he's probably going for a little longer. I might stream tomorrow, but if not, I will probably stream on Friday. So bye for now.